Hello everyone, thanks for tuning in to Solar Sunday. So we wanted to bring you Solar Sunday at the beginning of August. That's why we had it penciled in right way back from around the last update that we did in April, the last Solar Sunday in April. We had it penciled in that we would do a Solar Sunday at the end of July or the beginning of August. Unfortunately, we was unable to bring you Solar Sunday due to circumstances outside of our control at the beginning of the month. But we have freed up a bit of space, a bit of time on this last Sunday of August to bring you Solar Sunday. So we're going to go over the Solar Cycle 24 data in a moment. Got all of the trackers updated from our good friends James Ackrill and Richard Shaw. So we'll bring you up to date with all of the latest developments with Solar Cycle 24. And then we're going to talk again about the NASA forecast for Solar Cycle number 25, that being the second part of the videos, and we'll be discussing about whether we might go down to Dalton minimum type levels of solar activity with Solar Cycle number 25, and if we do, what could the impacts on that be? So that being the second part of the video, but the first part of the video, going to deal with all of the Solar Cycle 24 information. So, before I get on with all of that, just to say that going to be a busy day today at GasWeb. So we're going to have the final GasWeb Sunday Roundup. That's going to be with you after lunch. Well, for one last time, we're going to go through the GasWeb Sunday Roundup, and then they'll be put on the back burner from next Sunday. When the winter updates begin. There'll be no point doing any more Sunday roundups with winter updates, because we'll be covering the same ground in both of the videos. So, one last GasWeb Sunday Roundup coming up this afternoon, and also later this afternoon after that, we're going to have the little sneak peek for winter of 2019-2020. That's going to be quite an interesting watch. I'm just going to talk you through the methodology, explain what we're going to be talking about through the winter updates, but there will be one or two long-range models included in that one for you to get your teeth into as well. So that's what's coming up today. Tomorrow, Terry Scoley's autumn forecast is going to be released, and we'll also, of course, have the Bank Holiday Monday historic video this holiday. We're looking at the autumn and winter of 1930. Sorry, it's been a very long day. We're going to be looking at the autumn and winter of 1938-1939 for this Bank Holiday Monday historic video. Seems rather a strange choice, I think, but you'll find out in video why we have chosen that particular sort of autumn winter. You'll find out when you see the historic video tomorrow. Right, so let's get on with Solar Sunday. We're going to begin by having a look on the solar disk on our side of the disk today from solarham.net. So once again, we are spotless. We have a spotless solar disk on our side of this. There's no sunspots whatsoever. Solar activity is at very low levels being reported by SolarHam and is expected to remain at very low levels over the next 3 days, which is what you'd expect given we are now well and truly into solar minimum. This is the GasWeb Solar Sunday activity tracker updated by our good friend James Ackrill up to the 22nd of the month, 22nd of August. So this is how we're looking right now. Very, very indicative of being at solar minimum. Really, so the orange line here is depicting each individual day's sunspots. You can see we are having long stretches now, very, very long stretches without any sunspots at all. One or two still coming through, but overall, more days now have no sunspots, are spotless. There are more days doing that than the days that have sunspots. So we are at an incredibly minimal level of solar activity now. That means our trend lines, which are the thick green and the thick red lines, they're kind of like on the floor of the chart. So there's very little happening in terms of solar activity. You can see how we've taken a step down over this summer, really, since sort of earlier into the year. back into last year. So this takes all the way back to August last year, and you see then we was having regular regular sunspots, regular solar activity, and the days where we had sunspots were outnumbering the days where we were spotless, if you like. So we were getting days last year and into the early part of this year, we were getting days that didn't have any sunspots, so were spotless. But the days that had sunspots, if you see what I mean, were more numerous compared to the days that didn't. Now it's the reverse, really, since May. This is when the change happened, the middle of May. We have more days now that don't have sunspots than days that do, which tells us again that we are into solar minimum now for solar cycle number 24. This pink line up here, don't often get a chance to talk about this. This is depicting solar flux. So solar flux is kind of like the noise that's coming out of the sun. And you can see that also looks pretty quiet. We are getting these spikes here that we was sort of back into the earlier part of the year. Now we're just sort of flatlining at this level. So even in terms of solar flux, that looks like it's gone pretty quiet as well. So this is telling us how many spotless days that we've had. For the current stretch, it's 181. For 2019 in total, so far, it's 161 just there. So 161 days so far in 2019 have had spotless days. That's 68% of the year, which is up on 2018. 2018 had a total of 221 spotless days, which was 61% of the year. So you can see that actually looks like 2019 is going to be probably the solar minimum winter compared to 2018. Going all the way back into the middle part of the solar cycle, where it was around solar maximum, you see we have days here, for example, 2015. Every day in 2015 has sunspots. There are no days in 2015 that are spotless, 0% of the year. And the same is true for 2013 and 2012, albeit that's at quite a low level of solar activity, so they're quite weak sunspots, if you see what I mean. But every day in 2012, nevertheless, and in 2013, nevertheless, still had sunspots. Comparing to the last solar cycle, we see that, so 2008 has 268 days, 73% of the year that were spotless, and 2009 has 260 days, 71% of the year. Now, that's interesting because, of course, it's 2008, that is the solar minimum year, but 2009 is only just under it, actually, at 71% of the year, 260 days. So it shows that it was a very delayed start to solar cycle number 24, which of course we know that already. This one is telling us that 93 out of the last 100 days have been spotless. That's 93%. That shows us we are well into solar minimum. And this, of course, part of the special Solar Sunday Gaz Weather 2019. Big thank you to Richard Draught for sending those through. Right, so back to James Ackrill's chart. So this is showing solar cycle number 24 throughout the cycles from beginning to where we are, which is virtually at the end of it now, depicting each individual month's sunspot number. So again, you can see the solar cycle begins in 2008. It reaches its first maximum at the end of 2011, or the beginning of 2011, I think it was. And then it reaches, no, it's at the end of 2011 when we reach the first solar maximum. The second solar maximum, though, the second peak of solar cycle number 24 was the strongest one, and that occurs at the beginning of 2014. So solar maximum for this solar cycle happened in 2014. You see the very slow, gradual climb up into the solar cycle number 24. Took a long time to get going through 2009 in particular, very weak solar cycle, and even into 2010, very weak solar cycle. It wasn't really until 2011 that it finally took off, and then it was at a pretty modest sort of level. So we get the maximum of this solar cycle, number 24, occurring at the beginning of 2014, and then since then, of course, we've been trending down. So it's not a linear process, so you'll sort of drop down, and then you'll go back up again, and then you'll drop down, and you'll go back up again, and you'll drop down a bit more, and then you'll go back up, and so on. So it's not a linear process. Some months are bucking the trend as you move downwards into the declining part of the solar cycle, but eventually, inevitably, you find yourself arriving at solar minimum, and that's where we are now. We are now back, basically we're back to kind of levels we were at the beginning of the solar cycle. So you see that for the last couple of months, these two orange spots just here, that's going to be for June and for July. You can see they, again, on the floor of the chart. We have quite a few spots actually that are on the floor of the chart. We've got another one just there, then we've got one just there too. So again, we're very much around the level that you'd expect for solar minimum, and it's just a case now of when we will come to the end of solar cycle number 24 and start moving into the beginning of solar cycle number 25. This is showing us solar cycle 24 set against the last solar cycle, number 23. So you can see that, again, weaker cycle, this one compared to solar cycle number 23. That's where we peaked with solar cycle number 23. 23 started in 1996, ended in 2008. Look how much stronger solar activity was in solar cycle 23. Very quick ramp up out of solar minimum into solar maximum. It happened very, very quickly, whereas this solar cycle much slower to get going, and when it did peak, it was a much weaker peak compared to the solar cycle that preceded it, number 23, and then the drop down into solar minimum happens quicker actually than it did with solar cycle number 23. That's quite a slow sort of decline in solar activity. So it's a much bigger curve upwards, and it's a much bigger curve downwards with solar cycle number 23, telling us that it was an active solar cycle. We very quickly went into solar maximum, and then it took a long time to come out of solar maximum and go into solar minimum. This one, much weaker solar cycle all round, much slower to get to solar maximum. The solar maximum itself was much weaker, and then the decline down into solar minimum has been rather quicker, I think, compared to solar cycle number 23 as well. And this one is showing us flux in terms of the two solar cycles. So again, you see a weaker solar cycle compared with 24 there for solar flux compared to solar cycle number 23, telling us that again this has been a much weaker solar cycle number 24 compared to solar cycle number 23. Now this chart is showing all solar cycles up to solar cycle number 24, and it really does highlight just how weak this solar cycle has been. Not the weakest recorded, but certainly it has been at the lower end of the range for solar cycles. So we've got every solar cycle depicted here, right way from solar cycle number 1 all the way down to solar cycle number 24. Number 24 is the red coloured line. So these are our most active solar cycles up here. They are very, very active solar cycles indeed, and included with them, I think, sort of solar cycle number 20, for example, very active solar cycle, that one. Probably solar cycle number 17, this blue line just here, would be included in that one as too. Solar cycle number 19, also this green line. I think that's possibly the most active solar cycle of all. So there are strongest solar cycles And then we've got sort of a mid-range solar cycles, these ones just here, and that's where most of the solar cycles tend to be. And within that, we've kind of like got solar cycle number 2 in there, and also I think we've got solar cycles number 21, solar cycle number 22, solar cycle number 23 in that mid-range. So that's kind of like where most solar cycles end up. Most solar cycles aren't as active as these ones, but also most solar cycles are not as weak as these ones. So let's come down to the weakest solar cycles. That's these ones down here, and of course it does include very clearly the red line, which is solar cycle number 24, the current solar cycle. So these are our weakest solar cycles of all. You see how long it took this solar cycle to get going compared to most of these other solar cycles. So look how quickly most of these lines are lifting upwards here. These individual solar cycles, they lift up very, very quickly. Whereas solar cycle number 24, along with all of the other weaker solar cycles, it has to be said, this is something that does happen when you have very weak solar cycles. This solar cycle took a long time to lift up. It's a very delayed start to the solar cycle, and when it did finally get going, we only sort of peak it at around there, and then very quickly start to fall away. So you see again how we're dropping away with this solar cycle much more quickly than most of these other solar cycles, which take a lot longer to get there. So the drop began rather earlier than would be expected towards solar minimum. The decline, I suppose, of the solar cycle began rather quicker than would be expected, and it happened a lot faster than the, many of the other solar cycles too. And we continue to be very, very weak compared to all other solar cycles. That's where we are right now. Within this solar cycle. So you see that generally this red line is still trending underneath nearly all the other coloured lines, interestingly. So even as we go into solar minimum, we do so at a reduced level of solar activity compared to most of those other solar cycles, which is really quite interesting how that is happening and how that is occurring. Even now, right up the depths of the end of solar cycle number 24, we continue to be at the very weakest end of the solar cycle. Most of these other solar cycles don't reach solar minimum until this sort of area just here, which is a few months further on. So it is continues to be a very, very strange and very much weakened solar cycle that we see here with solar cycle number 24. This is how we compare to all of the weakest solar cycles. So we take out all of those active solar cycles and we just have those very weakest ones. It's solar cycle number 5 and number 6. They're the two Dalton minimum solar cycles, the very weakest, these two lines just here. Also solar cycle number 12, solar cycle 14 and solar cycle 16. And then, of course, we've got solar cycle number 24. So, again, comparing two solar cycles, what we can say is that we didn't have a Dalton minimum with solar cycle number 24. We see that the maximum that occurred with this solar cycle was kind of on a par with solar cycles 12, 14 and 16. So they're very weak solar cycles, don't get me wrong, but they're on a par with the solar maximum was on a par with those, whereas the other two are the two Dalton minimum solar maximums. They're these two just here. So, didn't have a Dalton minimum, but we did have a much weakened solar cycle compared to what we've had for a very long time, probably since, well, definitely since solar cycle number 16, which I think happened at the start of the 20th century. And then, of course, we have a very quick fall away into solar minimum. So, the maximum occurs just there, then we decline the solar cycle down here. And that's where we are right now. So out of these weakest cycles, we're kind of like at the weakest range. Interestingly, the two Dalton minimum solar cycles 5 and 6 are these two lines just here. And they were a little bit more active, especially number 6 at this point in the solar cycle, at this declining point of the solar cycle. But of course, the key with them is that the maximums were quite a bit weaker. But that's where we are right now anyway, solar cycle number 24. So that tells us we've got a little way to go with this solar minimum. We're probably not quite finished with solar minimum yet. I would suggest solar minimum is likely to occur probably through the first half of next year. That's when I think we'll be at the range of the end of this solar cycle, I suppose I should say. The end of solar cycle 24, I think, will occur in the first half of next year. And the beginning, therefore, of solar cycle number 25 will be the first half of next year as well. You never know, all solar cycles are a little bit different, but it does look as though, on average, with these weaker solar cycles, we have still a little way to go. Most of these lines are finishing around there, so that's sort of 9 months, perhaps 6 to 9 months on from where we are right now. We do have this one that's even further on. That will be over a year. If we went along with solar cycle number 6 and had our had the end of solar cycle at this point, then we would be probably into the beginning of 2021 even, I would have thought, with that. Certainly the end of 2020. But that one's doing things a little bit different. Most of these solar cycles appear to end around there, which is probably going to be kind of 6 to 9 months on from where we are right now, which takes us into the first half of next year. Last thing I'm going to show you with the trackers is the solar cycle 12 and solar cycle number 24 comparison. So, of course, we've talked about this a lot in videos over the past years. There has been this uncanny resemblance between the solar activity that we had during solar cycle number 24, this current solar cycle, and the old solar cycle number 12, which ran, I think, from 1877 to around 1890, something like that. So you see how both these solar cycles have a very slow lift up in solar activity into the first maximum, then kind of leveling off for a year or so, and then going into the second peak of the solar maximum. And the second peak is the true solar maximum of both of the solar cycles, quite interestingly. That's a little bit different compared to a lot of solar cycles. You do tend to get 2 peaks, 2 maximums, but the first peak tends to be the maximum, and the second peak is usually a little bit weak, but these 2 solar cycles did that the other way around. And then you see how the decline of solar activity is very much linear as well. Remember, the orange-red line, that's solar cycle 24, the green line is solar cycle 12. So you see how the 2 solar cycles are comparing with one another, albeit through most of it, actually, solar cycle 24 tends to be rather weaker than solar cycle 12. They do lift up and reach their maximums in a very similar way, but throughout the lift-up phase, this period just here, generally solar cycle 24 is a little bit weaker than solar cycle 12. In the maximum, solar cycle 24 again tends to be a little bit weaker than solar cycle 12, and then in the declining phase, generally solar cycle 24 has been a little bit weaker than solar cycle number 12, particularly around this point just here. Where we are right now with solar cycle number 24, the current solar cycle, is just there. You see that solar cycle number 12 had a little way to go. It did have one last little push up in solar activity just there. Interesting. That would be in around 2 or 3 months' time. So if we get that little tick up in activity that we had at this point, it's actually quite a big tick up in activity given the fact that it's in the solar minimum of solar cycle number 12. If we do get that tick up, then we will continue to be trending very closely to solar cycle number 12. But it does tell us that we've still got a little way to go for this solar cycle. We haven't quite reached the end of it yet, probably. That's where solar cycle number 12 finished just there. So we're around, again, that's probably around 9 months, perhaps, from where we are right now. Let's see how many of those green dots there are. So there's that one, that's 1, that's 2, that's 3, that's 4, that's 5, that's 6, that's 7, that's 8, that's 9, 10, 11, 12. So we could have as much as a year left for solar cycle number 12, for solar cycle number 24, if we continue to trend along the path of solar cycle number 12. One of the interesting factors about solar cycle 12 and 24 is that there was a connection through the earlier part of the solar cycle between the two winters of solar cycle 12 and solar cycle 24 seem to be very connected in their trends, colder than average and warmer than average, up to around the middle part of this solar cycle, and then we lost the trend a little bit. We'll be talking about that in the winter updates. That's something that we've talked about in the winter updates over the past 3 or 4 years. We'll be talking about that again in this year's winter update. Let's move back from stop to pause. We don't want to stop the video at this point, just pause it. So, yeah, we'll be talking about that connection between the winters of solar cycle 12, solar cycle 24 in the winter updates. It's one of the things that we've talked about a lot over the past few years' worth of winter updates, and this year will be no exception. So more about that. Not sure what update that's going to feature in. Might be next week's first update. It might be after that at some point, but we will be talking about that in one of the winter updates within the next week or two, I would have thought. Right, I'm going to pause the video there, talk for 25 minutes, gone over all of the data for solar cycle number 24. Hope you found that interesting, brought you completely up to date to where we are with solar cycle number 24. I'm going to pause the video there, get myself a little drink of water, and when we come back, we're going to talk about NASA's forecast for solar cycle number 25, have a little bit of information about that, so more about that when we return. Get yourself a couple of biscuits and a cup of tea, and I'll see you back here in around 2 seconds time. Okay, we're back, and we are ready to resume what will be the last Solar Sunday of the year. This will be the final Solar Sunday of 2019. We wanted to do this video at the beginning of August, but we wasn't able to get it in then. We freed up a little bit of time. We decided to bring you Solar Sunday here on this last Sunday of August, ahead, of course, of the winter 2019-2020 updates that are going to be getting underway. They'll be getting underway in a week's time. Exactly this time next week, actually. So, we talked in the first part of the video about Solar Cycle 24. We brought you up to date with all of the latest information there. We brought you up to date with all of the trackers. The second part of the video, we're going to talk about Solar Cycle number 25 and NASA's prediction. Now, we focused on this quite a bit in the last Solar Sunday that we did in April, but I just want to go over this prediction again. So, let's remind ourselves of what NASA is saying about Solar Cycle number 25. So this was released back in April. It formed the basis of the last Solar Sunday that we did. So the headline from the National Weather Service is: solar experts predict that sun's activity in Solar Cycle 25 to be below average, similar to Solar Cycle 24. April 5th, 2019, scientists charged with predicting the sun's activity for the next 11-year solar cycle say it's likely to be weak, much like the current one. The current solar cycle, cycle 24, is declining and predicted to reach solar minimum, the period where the sun is least active, in late 2019 or 2020. I think that's going to be more into 2020, I have to say. Could actually be quite well into 2020, I think. But we shall see about that. It goes on. Solar Cycle 25 prediction panel experts said Solar Cycle 25 may have a slow start, but is anticipated to peak with solar maximum occurring between 2023 and 2026 at a sunspot range of 95 to 130. This is well below the average number of sunspots, which typically ranges from 140 to 120 sunspots per solar cycle. The panel has high confidence that upcoming solar cycles should break the trend of weakening solar activity seen over the past 4 decades. So, each solar cycle from, I think, around solar cycle 21 onwards has been weaker than its preceding solar cycle. They're saying at NASA, it's a rather bold prediction, I have to say, they're saying that this solar cycle should break that trend. There's a quote here: we expect solar cycle 25 to be very similar to cycle 24, another fairly weak cycle preceded by a long, deep minimum, said panel co-chair Lisa Upton, PhD. solar physicists with the Space Systems Research Corp, the expectation that solar cycle 25 will be comparable in size to cycle 24 means that the steady decline in solar cycle amplitude seen from solar cycles 21 to 24 has come to an end, and that there is no indication that we are currently approaching Maunder minimum type levels of solar activity. So not Maunder minimum, but what about Dalton minimum? So this is how the sunspot number is predicted compared to the past 3 solar cycles. So this is solar cycle 22's maximum just here. That's solar cycle number 23, and that's solar cycle number 24. You see how those solar cycles have shown a decline from there to there to there, a steady decline downwards. The mean forecast from NASA is just here, which is virtual. To me, that actually looks a little bit weaker with solar cycle 25 compared to 24. So to me, that actually looks as though it's a little bit weaker. But okay, let's say that's on a par with the maximum that we had with solar cycle number 24. So they're going for a solar cycle with 25 that's very similar to solar cycle number 24. Now, what they're not showing with this is that there would be a margin of error. There would be a range of outcomes, and they've gone kind of like for the medium most likely range. So you would have an outcome within this prediction that would give a maximum up here that would actually be stronger than solar cycle number 24, but you would also have an outcome that would be weaker. That would be down here, and if that happened, then we would continue the trend of solar cycle 25 being weaker than its preceding solar cycle. The maximum would be something like that. Let's get rid of that and do that again. So we would do something a little bit like this with the curved line if we was at the weaker end of the range, if you like, and obviously that would be under there. So although this is like the medium range, the central range of their prediction, there would be a range that would be up here to all the way down there. If we did have an outcome that was down here at the weaker end of the range, if you like, if we was down there, then that would take us down to Dalton minimum levels. Remember, at this point, on the charts we just looked at this point within the solar cycle of 24 and 25, because they're both around the same ballpark, we are still at the lowest range of solar cycles. We're still at the weakest end of the solar cycle. So if we went any weaker than this, then we would be down in sort of Dalton minimum type levels. Now, this is the NASA forecast for solar cycle number 24 as of the beginning of the cycle. This is from February 2009. I had to Google to get you this. So, again, we have, they're not doing this this time. So they show you with this, the sort of strongest range down to the weakest down here of their prediction. So that would be the weakest end of their prediction. That would be at the strongest end of their prediction. And their prediction at this point, early in solar cycle number 24, will probably be somewhere in the middle, somewhere around here. Now, what actually happened with solar cycle 24 is that we came out at the weaker end of the range. I'm not sure why they aren't showing us the strongest to the weakest range this time. They're just showing us kind of like the medium range, which they think is the most likely just here, but they're not showing us the strongest this time, and they're not showing us the weakest. Maybe that's because if they did show us the weakest end of their range, which would be down there, that could start to set alarm bells ring a little bit, because when they did this last time, made these predictions last time back at the beginning of solar cycle 24, and where we came out with this solar cycle, it was much more, this solar cycle was much more like the weaker end of the forecast, this line. It's been much more like that than the strongest end of the forecast, which was like that. So you see with the stronger end of the forecast how quickly into solar maximum we went, which of course we know that was totally wrong. It was a much slower rise into solar maximum, and the solar maximum when it did occur was much weaker. And then much more gradual sort of drop down into solar minimum, or rather quicker actually drop down into solar minimum. So this is showing that after the big peak of solar cycle 24 that was possible in the higher end of the range, there was a quick drop down. But actually the drop into solar minimum has been quicker than this is showing as well. This is quite a delayed sort of drop into solar minimum, whereas actually we've had a quicker drop into solar minimum than that shows. So at this point in when was beginning solar cycle number 24, that was the range of outcomes that we had from the the stronger end of the range to the weaker end of the range, and we have come out at the weaker end of the range. So I say that this time they're not showing us the range; they're not showing us the strongest range all the way down to the weakest range. But if we did come out at the weaker end of things with this solar cycle, then we would be down to Dalton minimum type levels of solar activity, and that's how we would look. So I saw this on Twitter a few months ago and saved it. That's how solar cycle number 25 would look if it went down to Dalton minimum type levels in comparison to solar cycle number 24. I'm not sure who created this, but whoever it is, big thank you to you for creating this chart. But let's say that's how we would look if we started to drop into sort of Dalton minimum type levels for solar cycle number 25's maximum versus solar cycle number 24 versus solar cycle number 23 versus solar cycle 22 and 21. And that would indeed, therefore, continue the weakening of solar cycles from 22 to 23, 24, down to 25. And, of course, that takes us to Dalton minimum type levels of solar activity. There's the Dalton minimum solar cycles there, the two solar cycles of Dalton minimum, number 5 and number 6 as well. This is from Wikipedia, so this is showing how the Dalton minimum compares to the Malden maximum and also to the Maunder minimum. So NASA are saying there's no chance of a Maunder minimum type situation occurring with solar cycle number 25, and you can see the reason for that, and I think that's probably fair enough for that prediction, because Maunder minimum beginning back at the beginning of the 1600s, actually it began earlier than that, probably as early as the 1400s, certainly 1500s, and from around 1650 through to 1700, virtually no sunspots at all. We went through something like a 50-year perhaps period with incredibly low levels of sunspots, and then we come out of the Maunder minimum, start to lift up into, albeit very weakened, but a weakened state of solar activity in the second half of the 1700s, before we get this drop into the Dalton minimum. That's what we're interested in for solar cycle number 25. Can we get to Dalton minimum solar cycles 5 and 6 type levels? After the Dalton minimum, the trend generally is lifting up, although there was another little much less pronounced decline around the beginning of the 20th century. But overall, solar activity lifts up through the 20th century, reaches the modern maximum that we have just there through particularly the second half of the 20th century. That, of course, just there is solar cycle number 24. We haven't got on this chart yet solar cycle number 25, but again we depict how much weaker solar cycle 24 has been compared to solar cycle 23, 22 and so on. And then we go through to this page. So this is from Electroverse, and I'll leave a link to electroverse.net in the links page in the links in the description box, I should say, at YouTube. Probably links on the links page at Gasworth. Is actually quite an interesting piece. I won't go over the article, but they have got quite an interesting picture in there, but it's based on that Wikipedia image that was just looking at, but also including the NASA prediction for solar cycle number 25. What they're saying is the NASA prediction for solar cycle 25. Remember, this will be at the lowest end of the NASA prediction, which NASA are not at the moment really giving much publicity to, but there would be a lower end for their prediction, and this will be at the lower end of their prediction, I think. So, again, it's the same chart as what we have with Wikipedia. There's the Maunder minimum just there. There's the Dalton minimum just there. There's the modern maximum just there. But this time it adds in how it would look at the lower end of the range of the NASA forecast if we went to that sort of level of solar activity. And, of course, that would get us then to Dalton minimum type levels, number 5 and number 6, maybe even ever so slightly weaker than solar cycles number 5 and number 6. And if that happened, then we would have had the weakest solar cycle ever recorded, I think, because actually the solar cycles, the 11-year solar cycles, are not really recorded in the Maunder minimum. We know they occurred during the Maunder minimum, but they were so weak that I don't think that the solar cycles are actually registered. If you like, the first solar cycle, number 1, begins at the beginning of 1700, I believe. Could be wrong about that. But anyway, you can see how weak this solar cycle would be at the lower end of the range from NASA. It would indeed take us into solar cycles 5 and 6 type levels. That, of course, is Dalton minimum type levels. Dalton minimum occurred from around 1790, 1800 to around 1830, something like that. And just to finish off, this is the Central England temperature page at Gasworth. This is showing every month CET through the decades and centuries from 1659, the first year of the century temperature, all the way down to 2019. I thought we'd just have a quick look at this so you can see what happened during those Dalton minimum years. So let's start at 1800. For example, we have cold winters through the Dalton minimum years of 1800, 1801. Not every winter is cold. 1801 is actually a milder winter. January, February CTs in the 4s, but then very quickly we're back into cold winters again. In 1803, for example, we have the CET of just 1.8. We carry on further down, and actually the winters get colder and colder as we go along. So we come down to 1814, which is a ferociously cold winter. Winter of 1814 has a January, or includes a January CT of minus 2.9. The winter before it in 1813 had a January CT of just 1.9, so that was a cold winter as well. 1815, again, very cold January at 0.3, almost a negative month. We have another one there in 1820 in January, coming out at minus 0.3. 1823 comes out at minus 0.1. Look at all these negative CET months that we have during the Dalton minimum. Of course, also, we have very, very poor summers a lot of the time as well. So we have 1816 right slap bang in the middle of the Dalton minimum. That year, 1816, has a central temperature just for the year of just 7.7. 0.89. It's one of the coldest years on record, although you only have to go back to 1814 for another yearly CT in the 7s at 7.8. So incredibly cold yearly CTs. It does include, of course, 1816, the year without a summer. So we've got January, February, which are both cold months at 2.7 and 2.1. March, also really cold, 3.9. April, 6.6, that's cold too. May, 9.9, that's pretty chilly. And then we come to the summer months, June, July, August, and also September, and they are just ridiculously cold. Really, June's CT is at 12.8. July CT, this is July, the CT is just 13.4, and August CT at 13.9 is just exceptionally cool, wet and miserable. September not much better at 11.8. That, of course, is the year without a summer. Now, the year without a summer in 1816 is occurring slap bang in the middle of the Dalton minimum. It is the primary cause of the year without a summer in 1816 was the massive volcanic eruption that occurred in Tambora. But of course, as we've talked about in previous Solar Sundays, there is a connection between having weak levels of solar activity and increased volcanism. So although the year without a summer, and that dreadful summer of 1816, is caused by the eruption of Mount Tambora spreading dust across the Earth and sulfur dioxide across the planet, although that's the primary cause of the year without a summer in 1816. Of course, you have to look at the very weak levels of solar activity that are occurring during Dalton minimum that are probably increasing volcanism anyway. So was that volcano eruption that happened and caused the year without a summer, was that volcanic eruption ultimately caused by the Dalton minimum? No one will be ever able to say one way or another. The volcano might have erupted anyway, but we do see the connection between very weak levels of solar activity and increased volcanism. And generally, this is just a very, very cool, cold time through the Dalton minimum. And particularly later on in the Dalton minimum. Remember, it occurs perhaps as early as 1790, and actually back there, it's not quite as severely cold as it is later on as you get through to the second solar cycle, that very weak solar cycle, number 6, which I think is the weakest solar cycle that we've had all the way back to solar cycle number 1. Now, of course, we're not saying that we're going to see a repeat of the extreme cold that we had during the Dalton minimum, because we have to take into account 20th century warming that has occurred. But what interests me about all of this is the feedbacks to blocking. So we've got no way of knowing, because we only started registering the Arctic Oscillation and North Atlantic Oscillation indexes back in the 1950s, and they are our measurements for blocking, essentially. So before that, we have no way of knowing how much blocking that we had through these Dalton minimum winters, but we must assume that they must have had very, very extreme levels of blocking. And by the way, blocking doesn't always mean you're going to be cold. So before I just sign off, let's just have a look at 1808 as we're here. So again, I've talked about this, I think, in one of the earlier Solar Sundays that we did, one of the very first ones. 1808, in the middle of the Dalton minimum, we get July 1808 with a central temperature of 18.4, and possibly, even probably, saw the temperature going up to 40 degrees Celsius back in July 1808. So within all of this extreme cold that is occurring during the Dalton minimum, we get a very hot July, and it possibly, those days during that heat wave that occurred during July 1808, possibly hotter than any day in the 20th century or up to now in the 21st century. Again, we'll never know one way or another, but it is possible, maybe improbable, that we reach 40 degrees in July 1808. So blocking doesn't always mean you're going to be cold. If there's one area or one place that's on the cold side of blocking, somewhere else has to be on the warm side of blocking. So I always have to remember that. But what interests me about this is the connection between weaker levels of solar activity and blocking. I think that's where the connection lies. And so when people are looking and doing studies on solar activity and they can't see an evident sort of temperature, cooling temperature during these weakened levels of solar activity, and also around solar minimums. I think instead what I should be focusing on is blocking, whether the Arctic and North Atlantic oscillations go more negative during these periods of weakened solar activity, and also around solar minimum, whether through those indexes we go more negative or not. But of course we only can go back to 1950 with those indexes, so we've got no way of knowing how the AO and the NAO would have looked during the delta minimum, but we have to think that the AO and the NAO would have looked very, very weakened during very negative, I suppose I should say would be a better word, would have looked very negative during those periods. So it's all food for thought, really. We're not saying that we're going to go into very, very extreme cold temperatures such as we had in the delta minimum if we do see solar cycle 25 going down to that kind of level. I'm not saying that anyway. Some of the forecasters and predictions perhaps are. That's not what I'm saying. I'm saying that we may see an increase in blocking, which will cause an increase in extreme weather patterns, probably. And at some point within that, we would get some substantially cold weather, particularly so in winter. Maybe 2 or 3 winters that would be pretty cold again, and probably summers, well, again we would still have our hot summers, of course, and the overall trend is towards warming through the 20th century, so that would still apply. But at the same time, if we found ourselves on the cold side of blocking, then we will find ourselves in a really miserable and poor summer. So I would expect the kind of swings that we've had with the summers during solar cycle 24. I mean, we've had summer 2007 and 2012 at one end of the range, real cold washout summers. At the other end of the range, we've had sort of summer of 2018. So I would expect that kind of thing to continue during solar cycle number 25 as well. It's going to be fascinating to see how it all develops and how it all unfolds, and whether this solar cycle will go down to delta minimum type levels. It will be very, very interesting to see if it does, what impacts that could have. Right, so that is it for Solar Sunday for 2019. I hope you enjoyed it. I'm so pleased we managed to bring this Solar Sunday to you at long last. We've been waiting so long to bring this to you since the beginning of the month. Finally, we've done it. So I hope you found it interesting and informative. Big thank you to James and Richard for their help with this Solar Sunday. And later on today, we're going to have Gazov's Sunny Roundup, and we'll also have that little sneak peek for winter 1920. Of course, all of this solar stuff will play an important role in the winter updates. They're getting underway in just 1 week's time. This video will be placed on the Solar Cycle 24-25 updates page, and there'll be a bit of a written summary going over everything that we discuss in the video once again. But in over 50 minutes, it's been a very long video, so I just thank you so much for sticking with it, and I hope you enjoyed it. At gone 50 minutes, that's all for now, and thanks for watching.